So in the last couple of videos, we first of all talked about adding and subtracting rational expressions with common denominators. And then we looked at finding the lowest common multiple of polynomials so that we could find a lowest common denominator. All of that to get us ready for adding and subtracting rational expressions with different denominators. And of course, your reminder that you have quizzes due this week. Please check Pearson for the dates of which quizzes you have to do and when they are due. And a reminder that you should be working on your math every day. That's important when you're learning difficult subjects like mathematics. So we have some steps here. I would strongly recommend that every time you sit down to work on one of these problems, you have these steps beside you and that you follow through them until you're comfortable doing it without checking. So step one, we want to find the lowest common multiple of the denominators. That means we need to factor the denominators first. We've been doing a lot of factoring for the last couple of weeks. Once we find the lowest common multiple of the denominators, we need to multiply each expression by the missing factor or factors. Remember that you're multiplying the numerator and the denominator by the missing factors. We write all of this over a common denominator, simplify the numerator if possible, make sure you factor if you're asked to write your answer in factored form. If you're not asked for factored form, do not leave it factored. And finally, because we want the practice, we're going to find any restrictions. Okay, so step one is to find the lowest common multiple of the denominators. That means we need to factor the denominators. We've factored the denominators, and we see our first expression needs 3 times x plus 1. We also need a 2, so I'm going to write that up here with my 3. We have one factor of x plus 1. We need 2 factors of x plus 1. So there's our lowest common multiple of the denominators. 6 times x plus 1 all squared. Remember, we need to multiply the numerator and denominator by the factors that are missing. So when we look at 3 times x plus 1, here's the 3 and the x plus 1, we can see that we're missing 2 and a second factor of x plus 1. I'm just going to write that as 2x plus 2. So I'm going to multiply the numerator and the denominator by 2x plus 2. Actually, here I'll leave it factored. Is that okay? Now, in my second expression, I have 2 and 2 factors of x plus 1. I have the 2 and both factors of x plus 1. All I'm missing is the 3. So I'm going to multiply the numerator and denominator by 3. If you need to rewind the video and watch that part again, please do so. So we can write all of this over our common denominator, 6 times x plus 1 all squared. My numerator, I have 1 times 2x plus 2. That's just 2x plus 2. And 8 times 3 plus 24. So we have 2x plus 26 all over 6 times x plus 1 all squared. I hope you see this can be simplified. And remember, we were asked to leave our answer in factored form. So first of all, we see that 2 is common in the numerator. And we see that 2 can be factored out here, leaving a final answer of x plus 13 all over 3 times x plus 1 squared. What about our restrictions? Remember when we talked about restrictions, we haven't done that for a little while now, we said that the denominator cannot equal 0. And we usually went back to the very beginning. Well, the only factors with x are x plus 1. These are all the same factor, x plus 1. So we know, if we're talking about restrictions, that x plus 1 cannot equal 0. That tells me that x cannot equal -1. I don't need to worry about this 2. There's no variable there. 2 cannot equal 0. Same reasoning for 3. There's no x there, and 3 will never equal 0. Okay, interesting questions. X minus 3 and 3 minus x are not the same. How do we deal with those? I hope you remember that they are opposite factors. We could write this as -1 times x minus 3. Now we see that the lowest common multiple is -1 times x minus 3. And in fact, I can write +7 over that common denominator because both factors, the -1 and the x minus 3 that we needed for our lowest common multiple of the denominators, are there already. But we're missing factors here. We're missing the -1. So both the numerator and the denominator have to be multiplied by -1. This gives me +1 all over -1 times x minus 3. I hope you remember that we never leave a negative in the denominator. So we could write this as -1 in the numerator over x minus 3, or we could write the negative outside of our expression. Both of those are fine. What about any restrictions? I hope you also remember we said that when we have opposite factors, they will have the same restriction. We see that x cannot equal 3. If I put a 3 in here, 3 minus 3 would give me 0. If I put a 3 in here, 3 minus 3 would give me 0. Question 3. Remember that any integer can be written over 1. Any expression could be written over 1 if I want it to be a fraction. That tells me that my lowest common multiple of the denominators for this question is simply 1 times y plus 5, or just y plus 5. And so I can go ahead and write my y plus 3 here, since it's already over the y plus 5. I see that the 2 is missing a factor. I'm missing my factor of y plus 5, which means you need to multiply your numerator and your denominator by y plus 5. Be careful because there's a negative sign here. So when we distribute, we have -2 times y plus 5. So we can simplify this, -y minus 7 all over y plus 5. This is fine. But if you decided to factor out the negative, think about that. I hope you see that this is an equivalent expression. This also would be correct. What about our restrictions here? We only have this one factor in the denominator that contains a variable. So we see that y cannot equal -5 because -5 plus 5 would give us 0. A 0 in the denominator. Let's just try one more for this video, and then I'd like you to practice a little bit before you go to the next one. So we first have to find the lowest common denominator. Why don't you pause your video and do so? To find the lowest common multiple of the denominators, you had to factor both denominators. You use both factors from the first expression. We already have 2x plus 1. We don't need another one. And x minus 2. Oops, I don't know why I put that there. Get rid of that. So now we know that this whole expression can be written over 2x plus 1 times x minus 1 times x minus 2. We need to multiply the numerator and the denominator over here by its missing factors. So what's missing? We have 2x plus 1 and x minus 1. We see that we're missing the x plus 2. So we have to multiply the numerator and the denominator by that missing factor, x minus 2. So here, and for our second expression, we have 2x plus 1 and x minus 2. We see that we're missing x minus 1. So we need to multiply the numerator and the denominator by that missing factor. Why don't you simplify that and find the final answer in factored form? You should have used the difference of squares formula for each of these, a squared minus b squared, to multiply those. And you should have paid attention to this minus sign. We are subtracting all of this. So we could write this as x squared minus 4 minus x squared plus 1 all over that common denominator. This simplifies then to -3 all over our lowest common multiple of the denominators in factored form. And our restrictions, looking at each factor, These are our restrictions. I'm not sure if Pearson always asks for them, but you should be aware, again, that the denominator cannot equal 0. Our answer to this question is over here.